Oops. Okay, sorry. So I wasn't hitting record earlier. What I mentioned to the class earlier is this is the calculator you really want to borrow or purchase. I think I haven't been in so long, but I think at Carrefour it's like 100 reals. It's a bit expensive actually, but such a good purchase. I wish I had this when I was in university. The reason I'm mentioning this is because this chapter is about percentages. So, like percents, fractions, decimals, this calculator can do it all. It's a Casio FX85. All right, so make sure at some point you need to borrow this or buy this. It's such a good calculator. Again, I've said this before, but like, um, I wish I had this when I was in university. So, just a very quick introduction today of chapter 3. We will do test review Tuesday or Wednesday this week. I will have a review. But today I am going to move into chapter 3, which is, like I said, about percentages. And this calculator that I showed you guys can do it all. It's amazing. So let's start with review. Let me zoom in here and kind of explain why this calculator is so good. First things first, we are going to be talking about percentages, which are fractions. And everybody hates fractions. Nobody likes fractions, but it's it's a pretty straightforward concept for this chapter. A proper fraction. So I'm right here if you're following with me in the notes. A proper fraction would typically have two parts. It would have a numerator and a denominator. So a number on the top and a number on the bottom. And your calculator can, of course, replicate this with a button, which I'll show you in a minute. I'll kind of, I don't know how I'm going to do this, but I'll try and show you my calculator screen in a minute. An improper fraction would be, it's obviously same as a fraction, but it has a numerator greater than the denominator. And a mixed number is a combination of numbers and fractions. So it's a whole number combined with a fraction. So on your calculator, and I'll put my camera on in a second, so you should kind of watch what I'm doing on the screen. This calculator is amazing. So if you can see my face, don't mind my hair, you can see the calculator. And there's a button here. Nope. I'm trying to like show this with this finger here. So this button, if you can see that button, it's a fraction button. It will create fractions. I can show you how to change it into decimals. I can show you how to change it in percents. I mean, this is, I wish, like I said earlier, I had this in school. So this button, where this finger is your fraction button. And this button here will create fractions, and you can change them into decimals with this button. All right, this SD. I don't know. I looked this up before. I don't really know what SD means. It might be like standard form and then into decimal form. But this button is amazing. So, like, for example, it says in my notes, if you're looking at the screen, a proper fraction has a numerator less than the denominator, and it says 6/11. So I can put this into my calculator. I'm going to hit 6/11. So I don't, oh, oops, sorry. I don't know if you guys can see that. So 6 over 11. And then I can hit this button and change it into a decimal. Right? So like this calculator, if you can get one, they're available at like Carrefour or Lulu or wherever. They're like 100 real. You could also borrow this from another student at the college. This is the calculator we tend to use at the college. And I mean, it's amazing. So a proper fraction has a numerator less than the denominator, like 6 over 11. An improper fraction has a numerator greater than the denominator, so it would be like 23 over 7. And this would give you on this calculator a number bigger than 1. So if I hit SD here, you can see the answer is 2 point something. It's bigger than 1. An improper fraction would, when you calculate it, when you change it into a decimal, would be bigger than 1. A mixed number is a combination of a number itself and a fraction. I'm going to turn my video off because I hate looking at myself. So like you have an example here, which you can see on the screen if you're following what I'm writing. 5 and 3/4. This would be a combination of a whole number like 5, 6, 7, 8, and a fraction. Now, we're going to look at, like today, we're not going to go too deep today, but we're going to look at fractions today in a lot of detail. And equivalent fractions are any fractions, so 2 or more fractions, that have the same value but have different numbers. So, what's an example of an equivalent fraction? Like 2 over 3. So I'm talking about equivalent fractions here. So like 2 over 3 and let's say, I don't know, 6 over 9. These are what we would call equivalent fractions. They have the same value. If I put them into my calculator, they would give me the same decimal value. It's just that the second fraction has different numerators and denominators. It's because I multiplied them by something. So in this case, I multiplied them by 3. Higher order equivalent fractions are found by multiplying the numerator and the denominator by the same number. So like, I don't know, 2 over 11. An equivalent fraction, and I'm going with this, don't worry. There's a place I'm trying to get to. But an equivalent fraction, we can multiply these by 4. So I could get 8 over 44. These are equivalent fractions. And the reason this is important is because sometimes in pharmaceutical math or pharmaceutical calculations, you're dealing with fractions or typically what we would use as percents, and you're working with them. So you might have to make a solution, or you might have to make an ointment or a medicine that is like 6% of calamine lotion is an example. This 6% is a fraction. So we're kind of going to look at that a little bit today, and that'll kind of be it. So example number 1 here, 2 over 3 is equivalent to 10 over 15. It's a higher order fraction. And this is like when you're converting recipes, you're converting medical equations, you might need to deal with higher order fractions or higher order equivalent fractions. Example number 2 here, we have 12 over 14. Again, like if I can show you this calculator, I'll put my video on again. Hello. Watch what happens when I put 12 over 14 in this calculator. So I'll clear my numbers. I'm going to put in 12. I'm going to divide it by 14. Oops, sorry. You can see that here, kind of. I got another number in there. There you go. And watch what happens when I hit equals. So I hit equal and it reduced. It gave me a syntax error, 12 divided by 14 equals, there we go, 6 over 7, which you can see on this side. So this calculator will reduce the fraction for you. Sorry. 12 divided by 14, there we go. 6 over 7. All right, so this calculator will always, and this is kind of where it gets a bit confusing, this calculator will always reduce fractions for you. So it's good to know what an equivalent fraction is. It's always a fraction, in the calculator's case, in its lowest terms. Putting a fraction, so I'm right here, putting a fraction in lowest terms reduces the numerator and denominator until no number will evenly or simply divide into it besides 1. So what that lets us do is convert numbers to fractions. So these practice problems are obviously very simple. It just says write the fractions in lowest terms. What I'm doing without a calculator is dividing each of these numbers by their greatest common factor, or GCF. So for 5 and 20, I know that the greatest common factor would be 5. What I mean is the number 5 is the biggest number I could divide into these. So when I reduce this fraction, I divide the top by 5. That gives me 1. I divide the bottom by 5. That gives me 4. And 5 over 20 equals 1 over 4. This is the lowest terms. Now, you guys have been doing this since you were children, probably. You probably looked at this in grade 7, 8, 9, I don't know. You did this in the college. You probably did this in Math 1700. But I would like to give you a few minutes to try this and practice these questions and see if you can reduce these to their, without a calculator. You can use your, you can use your heads or your phones or whatever, but try and reduce these to their lowest possible terms. And what that means is divide by the greatest common factor. So I'll give you guys a couple minutes for this. If you do have a Casio calculator, it will do this for you in seconds. So some of you might be able to do this very quickly, but give this a try. Try to reduce these fractions. And then I'll kind of explain where I'm going with this in a minute. All right, so try these. I'll be back in, I don't know, 2 minutes. Sorry, and there's a comment in the chat there. It's not a private message. Sorry, it says, "Is this stuff online?" It isn't easy. This is definitely going to be online, so you can watch this video, after this class. So this will be online. All right, take a few minutes, try these questions, and I'll be right back. All right, I'm getting some good answers. I only have, well, actually, one student is answering me, but I hope you guys are trying this. And, honestly, some of you guys might think this is like stupid or silly or whatever. That's fine. Let's look at the answers here. All right, so just give me 1 second. I'll get this set up. All right, so the key for these questions, I mean, okay, if you have a Casio calculator, it literally just does this for you. And I feel kind of bad as like a math teacher. It's kind of like a guilty thing to say, but like, yeah, this calculator will do it for you. If you don't have a calculator, which I assume some of you do not, um, you're going to have to use your phones, use your heads, like use whatever. And the key to this is to find the greatest common factor, what we would call in math the GCF. So the biggest number that divides into two of these. So I mentioned earlier the GCF of 5 and 20 was just 5. So let's look at some other ones. 8 and 64. Um, Definitely, straightforward. Some of my favorite numbers here, GCF would be for 8 and 24. I think it would just be 8, right? We could divide both of these numbers by 8. Um, and the thing about a GCF is you can practice. You can try as many numbers as you want. So I would start with 1. Well, not really, but you start with 1, but then you would go into 2 or 3. If the number is even, you could try 2. If the number is odd, you can try 3 and keep working up from there. And what I figure out, or what I will notice, is that I can divide both of these numbers by 8. So 8 over 64 gives me, if I divide both of them by 8, I get, of course, a 1 and an 8. So the lowest or the reduced fraction of this is 1 over 8, which is about 12.5%. So if I can show you my calculator here, I'll put my camera on again. Again, don't mind my crazy hair, but 12, sorry. 8 over 64. Every time I show you my screen, I keep clearing it, which I apologize about, but 8 over 64 is 1 over 8. There you go. So right there. And I can change this to a decimal if I need to, which I'm going to talk about in a few minutes. I can press the SD button right here. Press that, and it changes it into a decimal. So SD will change it from a fraction, 1 over 8, to a decimal, 0.125. Highly recommend that you guys get this. Okay, so what about the other ones? I'll turn my video off. 36 over 9, the biggest number that can probably go into those. 1, not 2, 3. So 36 over 9. I divide both of those numbers by 3. Oh, actually, this one, 36 divided by 9, is just 4, or 4 over 1. You could, if any of you guys did this and you said 4, totally fine. Okay, what about 24 and 44? Now, I don't know, right? Like GCF, I could try a few numbers here. 1 obviously works with every number, but why don't I try 2? So let's divide each of these by 2. I would get 12. 44 divided by 2 is what? 22? And I think I could keep going, right? Like 12 over 22 doesn't look to be the lowest number. So again, like this is kind of, I don't want to say guess and check, but like kind of, you know, you want to try some different numbers. So I'm going to divide these by 2 again. And I get 6 over 11. So my GCF here was 4. I could divide 24 by 4, and I could divide 44 by 4. Again, I didn't know that, but through my math, through calculation, I divided it by 2, and then realized I could divide it by 2 again, and I got my answer, 6 over 11. Cool. Thank you, Asma, for telling me the GCF there. All right, cool. So you guys can try the rest of these. I don't know why it's scrolling so slow. Wow, don't mind my computer here. So what about changing these fractions to decimals? Now, again, I mentioned to you, I'm going somewhere with this. There's a reason I'm explaining decimals and fractions and everything to you. When you're working in a pharmaceutical environment, a lot of times recipes or the ingredients of a medicine will be given to you as decimals. So there's a reason I'm kind of going so slow through this. So how do you change fractions into decimals? Well, there's 2 answers I can give you. One, you divide the numerator by the denominator. That sounds easy. It's not though. What I mean is in your head or on a piece of paper, that can be very challenging. And this is why you would use a calculator for this. Most normal humans, I think of myself as a normal human, would only divide these numbers using a calculator. Like for me, trying to divide 19 over 7, I could do this. What we would call this when I was younger would be long division, and I could write this on paper, you know, I guess it would be like what, 19, into 7, not 17. But why? You know, we have calculators. This is 2021. We can just do this on a calculator. So the easy answer that I can give to you guys right now is if you have to change a fraction to a decimal, just use your calculator. I don't know any other way to teach this to you. If you were doing this on like a test or a final exam, just use your calculator. So 7 over 35, and again, if you guys don't have a fancy calculator today, just open up the app on your phone. Just put in 7 over 35. That's it. That's all you got to do. So on my Casio, it gives me a fraction, 1 over 5. That's the reduced form of this fraction, but I'm looking for a decimal. So I press my decimal button and I end up getting 0.2. It mentions here, if rounding is not required, you're fine. You use a line over the numbers that repeat. So an example of this would be like if you had to do 1 over 3, your phone or your calculator would say 0.33333 forever. So for 1 over 3, you could just say 0.3 repeated. The line over the number means it's going on forever. If the number ends, meaning if there's no rounding required, just write your number. So I don't know. This is pretty simple. I'll give you a minute to try these. and then we'll check out your answers. Really, all I'm asking you is to put this into your calculator, because I don't know if many of you could like do 19/7 on paper. But yeah, try these, see if you get an answer. I highly recommend only writing maybe 2, maybe 3 decimal places. Don't go too crazy with decimals. Keep it to 3, we'll say. So I'll wait around for a minute and then I'll check your answers. Excuse me. All right, I'm getting lots of answers. This is I figured this because, again, like um, when you think about this course, and like especially think about what we did on Wednesday, doing some of those like IV questions or fluid questions. This is pretty easy. So I'm very happy I'm seeing lots of answers here. Again, there is a reason why I'm showing you this. So if any of you find this kind of stupid, or you've done this, when you were 12, 13, 14, I am going somewhere with this. So 4/5, I put that into my calculator, and excuse me, it gives me 0.8. All right, so that's it. 12/11. This is what we would call an improper fraction, which means it's going to be an answer over 1, and I end up getting 1. So, okay, this is actually a good teaching moment here. My calculator is saying this. It's saying 1.090909, blah, blah, blah. And then it ends with a 1. What you can do for this one is you could just call this 1.09, or you could call this 1.1, or you could call this 1.09 with a line over it. I don't know if that's correct, though, because my calculator is saying that this ends with a 1, which isn't a repeating decimal. So I would probably write 1.09 or 1.1. 19 divided by 7, put that into my calculator, and I get 2.714285, blah, blah, blah. So you can just say 4.71. If some of you said 2.7, that's fine. Again, this doesn't have to be perfect. Like this isn't chemistry. So a lot of the students I've had in here, I had in chemistry, where I'd be worrying about significant figures. There are no significant figures in this course. So, as long as you don't say 3, if you said 2.7, 2.71, 2.714, I don't care. That's totally fine. All right, what about an improper fraction? What do we do with those? Now, and actually, I don't really know how to enter that on my calculator. I assume to enter this on my calculator, I would just say 2 times the number. Yep, I figured. Okay, so to convert a mixed number into an improper fraction, this is maybe review for you. I hope it is. You multiply the whole number by the denominator and then add the result of that step to the numerator. So this is not something maybe you can do on your calculator. Maybe it is. Let me just try. So like 2 times 2 over 5. Nah, my calculator doesn't really do this. I want to change this fraction. So I'm here with number 1. I want to change this into a mixed number. I want to change it into a fraction. So what I do is I multiply the denominator by this number here. So 2 times 5. If I can zoom in, you can kind of see what I'm doing here. Hold on. So I'm multiplying these numbers, and then I'm adding the 2. So what it ends up being is 2 times 5, which is 10, plus 2 is 12 over 5. You always keep the same. Oops. It's really weird writing so zoomed in because my number or my letters kind of change. But yeah, you always keep the denominator the same. So 2 times 5 is 10, plus 2 is 12. This would be a fraction of 12 over 5. So let me show you this one. Let's look at number 3. I'm going to multiply these numbers and add the 1. So 3 times 3 is 9, plus 1 is 10 over 3. Again, I always keep the denominator the exact same. So 3 times 3 is 9, plus 1 is 10, 10 over 3. So why don't you guys try number 2 and 4? And then we'll look at the answers. And again, if you're wondering where this 10 comes from, it's 3 times 3 plus 1. If you're wondering where this 12 comes, it's 2 times 5 plus 2. All right, so try these examples, number 2 and 4, and I'll check your answers in a minute. And then we're almost done. Oh, and sorry, Asthma in the chat says to open mixed fractions on your calculator, press the shift button and then press fraction on your calculator. And yes, you're correct. That does work. I'll show you guys that in a minute. But Asthma has a very good answer there. All right, so take a couple minutes, try these, and then we'll look at the answers. All right. Okay. So let's have a look at these answers. One thing I'll mention before I get into the answers to this is Asthma in the chat told me about the shift button, which I kind of forgot here. The shift button on your calculator is how you get to most secondary functions. So I'll put my camera on again. You can see my beautiful face. I think you can anyways. I don't know. I can't see a copy of what I'm sharing. But There's a shift button here. Hold on one second. Okay, there we go. All right, sorry, I couldn't see myself, so I couldn't like see what I was sharing. So there's a shift button here on your calculator. This shift button, if you look above the button, there's yellow text. And the yellow text means that when you press this button, you will get any yellow feature down here. So like the colors are kind of matched up. So when I press shift fraction, so shift fraction, no, look at what I got there. Look at those 3 squares. That's my mixed numbers. So I can use or deal with mixed numbers using this calculator. I'll show you again. So I'm going to hit shift. So this button here is really hard if I'm going backwards. So shift, and then I'm going to hit the fraction button. And you can see I get mixed. You can see a 5 there, but you get the idea. So there's my mixed fraction button. Thank you for that, Aisha. All right. So, these are very simple answers here, or I think they are anyways. So for number 2, 1 times 6 plus 5. So that would be 11 over 6. And 4. This is a big one. So I'm going to take 10 times 12, so 120 plus 11, so 131 over 12. Oops, sorry guys. Hold on. Oh man, sorry. Give me 1 second. There we go. Sorry about that. It took me a minute to get back there, but 131 over 12. Perfect. Okay. So I think I'm almost done. I think what I'm going to do is end with percentages. And this is kind of where I wanted to get today. The reason I'm teaching you all of this information about fractions is because fractions are how we get percentages. And as a human, as a pharmacist, as anybody, you need to know how to deal with fractions. Percentages. Percentages are the easiest way of comparing two quantities. The literal word, I guess it comes from Latin, but percent means part of 100. Percent means per 100, cent meaning 100. So per 100 or divided by 100. Percentages are kind of numbers we deal with in everyday to-day life. So it could be a recipe. It could be, from your taxes. I know in Canada we pay income tax. So we would pay 13% or 15% income tax. Percentages are a number that humans deal with all the time. So how do you change a percent to a fraction, which is definitely something you guys need to know. What you do, there's 3 steps here. You first get rid of the percent symbol. Remove that and write the number as a fraction using 100 as the denominator. I'm going to show you this, don't worry. If the number is a whole number, you can skip into step 3. I'm going to show you all this. Step 2, If the numerator is not a whole number, then multiply the top and the bottom by 10 for every number after the decimal point. That's a bit of a confusing step, but the idea is if I had to change like, I don't know, 12.1 to a percent, I would put it over 100, but then I would have to multiply this by 10. And the reason for that is I need to get rid of the decimal. You definitely don't want decimals when you do this. Step 3, simplify that fraction. So we'll worry about this part if the fraction or if the number is given as a mixed number. We'll worry about that next day. But I got to laugh because in real life, I don't think you'd ever see this. But let's look at some of these. Okay, so let me do 1 and 2. Ooh, you got mixed numbers in there. How do I want to do this? Well, okay, let's skip 3 and 4 for right now. And like, I'm not putting X's through them because they're not important. It's just I don't want to deal with mixed numbers today. So let's look at 1, 2, 5, and 6. Okay, so for number 2, pretty straightforward. First things first, get rid of the percent sign, drop it, get rid of it. And then what you do, because you're getting rid of the percent sign, you put it over 100. That's kind of like, I don't want to say a gift, but like that's what you're doing. When you get rid of the percent sign, you need to replace it with something. You can't just get rid of it. So what we do when we remove the percent sign, we divide the number by 100. So I mean, this is really it. What we could do is we could simplify this fraction as 1 over 50, but that's it. We get rid of the percent sign, we divide it by 100, done. Number 2 is a little bit more work. So watch what's going to happen with number 2. So I'm going to write 0.25 and I'm going to put it over 100, but there's a big problem here. I have a decimal and I do not want the decimal. So what I'm going to do is I'm going to move the decimal 2 places to the right, which means I'm also going to move this decimal 2 places to the right, and I get my answer. Now, this isn't the final answer. I still need to reduce this fraction, which I can do by dividing by, I think, 25. Yep, and I get 1 over 400. Cool. So you get rid of the percent sign, you divide it by 100, and you move the decimal places if you need to. So I'll give you guys a minute or two to try 5 and 6, and then halas, we are done for today. So there you go. Oops, sorry. There you go. Try 5 and 6, and I'll be right back, and we'll check your answers. Again, don't worry about 3 and 4. We're going to look at mixed numbers next day. So you don't have to worry about 3 and 4. All right. So, okay, I'm getting good answers here from Loa and Reem and Lorena. Everybody, good answers. Okay, so let's have a look at these. Okay, sorry. So 7.5%. So first things first, get rid of the percent and put it over 100. So I would get 70. Sorry, my seven's a bit ugly there. 7.5 over 100. Now, this isn't a proper decimal. I'm not setting it up correctly. I need to move the decimal. So I would move this decimal over 1, which means I need to move this decimal over 1. Whatever you do to one, you have to do to the other. So I would get 75 over 1,000, which I mean, I'm going to use my Casio. I hope you guys buy this calculator or borrow one at least. This would give me 3 over 40. Where did I get that? Well, I'll tell you, I got it from my calculator, but if you're wondering, what I did is I divided both numbers by 25. And I cannot stress to you enough, your life will be so much easier if you get the Casio calculator, because when I put in 75 over 1,000, it gave me 3 over 40. All right, let me check the chat. It's going a bit crazy, which makes me scared that I made a mistake. Oh, sorry. Somebody just asked me a private message, but I'll answer this to everybody. The private message is, sir, do you have office hours? And yes, I do. So before I do number 6, I'll keep you guys in suspense. My office hours are listed on the homepage. Now, it's been a couple weeks, so you might not have seen it. So what I'm going to do, I'm going to go to the homepage and I'm going to click show all news items. This will show me like everything I've posted since the beginning of time. And you can see my office hours right here. Okay, so these are my office hours. Sorry, I'm just getting my pen. Monday 11:30 to 1, Wednesday 10:30 to 11:30, and then today Thursday 11:30 to 1. Oh, that's before Ramadan. But yeah, these are my office hours. I'm gonna have to fix these because this was set up when the Ramadan schedule was happening. But yeah, I'll fix this next day. Again, these were set up when Ramadan was happening, so they're a little bit different than what they would normally be. All right, so let's go to the last question here. Sorry, 250%. Okay. So first things first, get rid of the percent symbol, and I would write 250 over 100. Now, there are no decimals here, so I'm done in the sense that I don't need to change decimal places or anything like that. I just need to reduce this fraction. And I could divide both terms by 10, which would probably be easiest, or I could divide both terms by 5. And what I would get when I do that is 5 over 2, or sorry, divide by 50. And I'm doing that so quick because I'm just using the calculator. The calculator, Casio, again, I cannot stress this enough. Please go get one, borrow one, find one from a friend. You can borrow it from me. I have one if you guys need to borrow it, but get this calculator. It's so useful for reducing fractions. All right, so that's it from me, guys. Yeah, I hope you have a good day. If you have any questions, let me know. Other than that, that's it. Halas, we're finished.
Thank you, sir. Have a good day.
Yes, thank you too. Have a great day. Thank you, Lorena and Serena, or Zarina. I hope I'm saying your name right. Thank you, Asma. Have a great day. Thank you, Reem. Have a fantastic day. Be safe out there. Wear a mask. Wear your gloves. Take care. And thank you, Lawa. Have a great day.